Good morning. We are ready for the second video on section 2.4, the chain rule. The video yesterday showed you the chain rule and did several examples. Today we're going to look at some examples that look more confusing. It's just a matter of clearly figuring out kind of how to go about breaking them down using the chain rule. So, reminder, there's the chain rule with the derivative of f of g of x. And you should know the formula. It is f prime of g of x times g prime of x. And then you should also know that that represents the outside derivative of the inside unchanged times the derivative of the inside. So we did several examples yesterday. We did that one right there. There's the first one. There's the second one. There's the third one. There's the fourth one. And we did some trig ones to keep track of what the inside and outside function were. Okay, so now the next few examples kind of combine the chain rule with either the product rule or the quotient rule. And you have to keep track of whether it's really a product or really an f of g of x. And it's allowed to be both. Like this one, I would argue I see a product. I see x squared and I see 1 minus x squared to the 1/2. But I also see a chain rule. That square root has an inside function, 1 minus x squared, and an outside function, the square root of something. So good example where we're gonna need both the chain rule and the product rule. So before I do anything, let me do what I would encourage you to always do, which is rewrite it using exponents. So this is x squared, and then times 1 minus x squared to the 1/2. Haven't done any calculus yet, just rewrote it. Now, you have to be clear on whether this whole thing is an f of g of x, whether the whole thing is a product. If the whole thing were being raised to the 1/2 power, I would argue it's not here. But if the entire function was being raised to the 1/2 power, then that would be an inside-outside function. The outside function would be something at the 1/2 power. But this one you have to recognize is a product. I've got two functions being multiplied together. So we have to use the product rule to find this derivative. However, when we use the product rule, which I know you know is the first times the derivative of the second plus the second times the derivative of the first, when you get to the derivative of the second, I think that becomes a little chain rule because that second, the 1 minus x squared to the 1/2, is a composite function, has an inside function and an outside function. So this is a product. If you start by using the chain rule, if you move that 1/2 exponent way out front, that's illegal because the whole thing is not being raised to the 1/2 power. So let's product rule this. So, and this is going to take probably several lines here. F prime of x equals the first, which is x squared, times the derivative of the second, the derivative of 1 minus x squared to the 1/2. That's a chain rule. It's over here. So that's a chain rule. So the derivative of my outside function is something to the 1/2 power. So the derivative of something to the 1/2 power is 1/2 times that same something unchanged to, I need a new exponent here, which is 1/2. I'm subtracting 1 from the exponent. So 1/2 subtracting 1 gets me to negative 1/2. That says negative 1/2. So, and then I'm still doing the derivative of the second. So it's 1/2 times 1 minus x squared to the negative 1/2. And then the chain rule says times the derivative of the inside. The derivative of 1 minus x squared is negative 2x. Need another parentheses, I guess. I would argue that what I've done so far is still only the first half of the product rule. This is the first. That's the derivative of the second. Let's finish the product rule. Plus the second, which is just 1 minus x squared to the 1/2, times the derivative of the first. And the derivative of the first is x squared, its derivative is 2x. Let me go like this to make sure that we're clear. This is the first. This is the derivative of the second plus the second times the derivative of the first. So there's my product rule. Now, let's talk about cleaning this up. I keep getting in the way. but I refuse to move my picture. All right, let's talk about cleaning this up. That looks really, really ugly. We could do a couple things here. I see in particular, I might do this. I'm going to use baby steps. If I were doing this myself, I might do a couple things at once. But I see a 2 right there. That's on the bottom, and a 2 right there. Those might go away. Those cancel. And then to the left of the plus sign, I see an x squared and an x. That becomes x cubed. So I think I can simplify this left side. I guess I'll use red as still a negative. So negative x cubed. And then I still have 1 minus x squared to the negative 1/2. That's a negative and a 1. I think that's everything before the plus sign, negative x cubed. And then it's hard to keep track sometimes. All these, there's my plus sign between the two terms. So I'll put that in blue here. And then I don't think the after the plus sign cleans up any, so I might leave it for the moment. This is still 1 minus x squared to the 1/2 times 2x. Now, as far as what else could I possibly do to simplify that, I would argue I have a GCF. And we said factoring out a GCF is always a common thing to do. So I would say that just looking at the x's, I see a negative x cubed to the left of the plus sign. I see a 2x. They both have an x. Now, there's another piece to this GCF, but I might take out the x first. So let's just kind of use baby steps here. So if I take out an x, I'm left with negative x squared times 1 minus x squared to the negative 1/2 plus, now the x is gone. I might just put that 2 out there, and then 1 minus x squared to the 1/2. All I did there was factor out x. Okay. Now I would argue there's another GCF here that we have to be aware of. So look at these two. Let me highlight these. Look at this and look at this. I have something to the negative 1/2 and I have something to the 1/2. Well, there were my likes. Well, you guys know that we could take out a GCF. You've been taking out GCFs for years. So let me remind you what you do know. My picture keeps getting in the way. Let me go back here. Let me go here. That if it just said 3x to the 4th minus 7x to the 7th, you would take out an x to the 4th. You would take out the lowest exponent. And then while you know what that would be, what you're really doing is you're dividing it by the GCF, and you're subtracting exponents to figure out what's left. That would be 3 minus 7x to the 3rd. That's some straightforward GCFing. The GCF is the lowest exponent, and then to figure out what's left, you're subtracting exponents. Subtracting what was there minus the factor that you GCF'd out. Okay, so keep that in mind. That's GCF that we like. Now I don't know where I'm going anymore. Okay, there it is. Whoop, with it over there. Put it down here. I need more space. There we go. Okay, so we have a GCF. Those two things in green, the lowest exponent is the 1 minus x squared to the negative 1/2. That's of the two exponents, that's the lowest one. So that's my GCF. So equal. And I still have the x that I GCF'd out earlier. And now I'm gonna pull out a 1 minus x squared to the negative 1/2. And now I'm left with something plus something. Helps me to keep track of the skeleton form. So to the left of the plus sign, we like this, right? Because the left of the plus sign, the entire 1 minus x squared to the negative 1/2 was the GCF. I think all I have left is negative x squared. And that's all that there is to the left of the plus sign. Now, let me move this over a little bit. To the right of the plus sign, I still have a 2. But now what? there was a 1 minus x squared to the 1/2. I factored out a 1 minus x squared to the negative 1/2. I have to subtract those exponents. Remember over here, I subtracted x to the 7th, my original exponent, minus the exponent that I factored out. 7 minus 4 is 3. That's why that says x to the 3rd. That's easy GCFing. So now I had 1 minus x squared to the 1/2, and I factor out a 1 minus x squared to the negative 1/2. If I carefully subtract those exponents, 1/2 minus negative 1/2 turns out to be positive 1. I actually end up with 1 minus x squared to the 1st. And all I did to get that, is important that makes sense. All I did to get that new exponent is I did that exponent, which says 1/2, minus that exponent, which is negative 1/2. I subtracted them. Sorry, this looks a little weird. Okay. And so really, and I'm hoping I don't need it, but really there's a 1, that's to the 1st power there. I'm not sure you need that, but that's where that exponent would be. All right. Now let's keep cleaning this up. Now, I could, in cleaning things up, we'd only end up with negative exponents. So I would argue that this thing, since it's raised to a negative power, can move to the bottom as 1 minus x squared. On the bottom, it's going to be to the positive 1/2. That x far left still is there. Now let's just clean this up. Let's distribute that too. This is negative x squared plus 2 minus 2x squared. I'm almost there. Now I think that thing in parentheses just becomes 2 minus 3x squared. So I end up with x times 2 minus 3x squared all over. Now, to the 1/2 power, I might write it as a square root again. 1 minus x squared. Done. So the simplifying was tough, but a couple important things about this problem. Going back to the beginning, you have to recognize that it is a product first, not a chain rule first. It's a product. And in doing the product rule, you had to use the chain rule because the derivative of the second was a product. It's very tempting to start a problem like this thinking, oh, it's a chain rule. What's my outside function? But the entire thing is not a composite function. The entire thing here is a product. And then as far as the simplifying, the cleaning up is often ugly in these things. But that factoring out something to the negative 1/2 power as the lowest exponent happens a lot. Maybe the first time you've seen it, you have to do that enough to get comfortable with it. Okay. I think we're ready for the next example, which is not that one. It is this one. All right. So I think it's kind of the same thing here, except we have a quotient. Clearly that function is a quotient. But when I take the derivative of the bottom as part of the quotient rule, that bottom is a little chain rule because it's an inside function x squared plus 4, outside function something to the 1/3. So I might first, as you should always do, rewrite this as not with roots, x squared plus 4 to the 1/3. But you have to you have to quotient to recognize that as a quotient. So let's use the quotient rule, which you by now need to know. It's the bottom times the derivative of the top. So the bottom, which is x squared plus 4 to the 1/3. That's a 3. Times the derivative of the top, which is just 1, minus the top, which is just x, times the derivative of the bottom. The derivative of the bottom, that's a composite function. The bottom is inside x squared plus 4, outside something to the 1/3 power. So the chain rule says outside derivative. The derivative of something to the 1/3 would be 1/3 times that same something, unchanged, to the, now I need a new exponent. I'm taking the exponent 1/3, I'm subtracting 1. 1/3 minus 1 is negative 2/3. And then the chain rule says times the derivative of the inside. Well, that derivative of x squared plus 4 is 2x. Now that I finish, I got bottom derivative of the top minus top derivative of the bottom all over the bottom squared, which is x squared plus 4 to the 1/3 squared. So there, what do? I quotient ruled it. Okay. Now we have to be able to clean this up. So let's look for a GCF. I'm looking again. Here's this minus sign separates my two terms. Do I have any common factors on either side of that minus sign? They both have an x squared plus 4 to a certain power. So just like on the last one, we can factor out whichever one is the lowest exponent. And I would argue that my two factors of x squared minus 4, there's 1 to the 1/3. Oh, not there. And here's 1 to the negative 2/3. I can take out the lowest exponents, and the lower of those two exponents is to the negative 2/3 power. So I think that I can take out a GCF of x squared plus 4 to the negative 2/3 power, and I'm left with something minus something. And I'll put the bottom of this fraction when I need more space in a second. So now let's carefully figure out what we're left with here. So to the left of the minus sign, all that was there was that x squared plus 4 to the 1/3. But we just need to now very carefully subtract exponents. My original exponent was 1/3, and I am subtracting out the exponent that I factored out, which was negative 2/3. Now I got to be real careful. 1/3 minus negative 2/3 turned out to be positive 1. So all that turns into, I guess I can make it blue again, turns into be just x squared plus 4 to the first power. And again, where did I get that to the first power from? I took my original 1/3 exponent and I subtracted the exponent that I factored out. 1/3 minus negative 2/3 is 1/3 plus 2/3, which is 1. And then after the minus sign, I think the entire yellow box factors out. Like I took out that x squared plus 4 to the negative 2/3. So I can clean it up again. I see an x and a 1/3 and a 2x. I might write that as, I don't know, 2x squared over 3 maybe. Let me write that and then make sure that I like what that says here. 1/3 x times 2x is 2/3 x squared. So I think I did that right. All right. And now we can't forget about the bottom. Now, how can I write the bottom? It's x squared plus 4 to the 1/3 squared. When you raise a power to a power, you multiply exponents. 1/3 times 2 is 2/3. So I think this denominator could be x squared plus 4 to the 2/3. All right, I think I could keep going. Can't think of a reason to stop at this point. All right. So I think as far as cleaning this up further, I think this whole thing in green here can move to the bottom. It's a negative exponent. On the bottom, it'll give you a positive exponent. And on the bottom, it's going to be an x squared plus 4 to the positive 2/3. Tell you what, let's do this. Had what already was my x squared plus 4 to the 2/3. That was my denominator. And this green thing up top here that was x squared plus 4 to the negative 2/3 can come down here as x squared plus 4 also to the 2/3. And yes, for the next step, that's a 3, yikes. For the next step, I am going to add those exponents. Trying 3's little or tough. So now let's talk about the numerator. So now at the moment, I am trying to clean up this. Well, can I? The 4, nothing happens to the 4, but I've got like terms. I've got 1x squared minus 2/3 x squared. Well, 1x squared would be 3/3 minus 2/3. I think it's 1/3 x squared. So I think this becomes 1/3 x squared. I guess it's plus 4. All right. Let's keep going. We already said that on the bottom of this thing, I have x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3. I can add exponents, which is x squared plus 4 to the 4/3. Now, as far as the top, it says 1/3 x squared plus 4. it would be perfectly valid to not change that, but it's very common. Again, I'm thinking if it's a multiple choice question, as far as how simplified would it be, it's common to not leave fractions inside of fractions. So I'm going to do a little sneaky GCFing here. If I pull a 1/3 out of that, I would argue I'm left with x squared plus 12. And it's weird to take a fraction 1/3 out of a 4 like that. But I divided 4 by 1/3, which is 4 times 3, which is 12. And if that might not jump out at you, but I could certainly, to check that, I can distribute that 1/3 back in there, and I do get 1/3 x squared plus 4. And now, lastly, finally, the 1/3, I can move the 3 to the bottom. So I think this is x squared plus 12 over 3 times x squared plus 4 to the 4/3. How much fun was that? The answer is it was a lot of fun. Now, having said all of that, go back to the top. You have to recognize the original problem as a quotient. And while doing the quotient rule, we had to use the chain rule. The one before was a product. And while doing the product rule, we have to use the chain rule. Well, next example, I'm going to make one up here because I want to change what I'm doing here. Let's go with y equals 3x e to the x squared. So, I see a couple things. I see a product, 3x times e to the x. But then I have the whole thing is squared. Since the whole thing is squared, there were my legs again. Since the whole thing is squared, that's a composite function. My inside function is 3x e to the x. My outside function is something squared. You have to start with the chain rule. Once we get to the derivative of the inside, well, heck, that inside appears to be a product, so we'll have to product rule that. So again, real important you understand that you've got to start the chain rule here first, not the product rule or the quotient rule, but we're going to need the product rule. So the derivative, this is the chain rule. The derivative of something to the second power is 2 times that something to the first power. I'm not going to put that 1 there, but it is the first power. And then times the derivative of the inside. And that inside is a product. Now we have to product rule this, which is the first times the derivative of the second. Remember, the derivative of e to the x is itself, plus the second, which is e to the x, times the derivative of the first, which is 3. Now what? How to clean this up? We got to be real careful because I have the thing in green out front, and then inside in blue I have something plus something. So we have to be real careful taking out a GCF. I think I can actually take a GCF. I think I'm just going to clean this up first. Let's just look at this thing. I think that thing, which is something plus something, really I would argue that 2, the thing out to the left, that 2 times 3 times x times e to the x is kind of already out there as a GCF. Now let's take more of a GCF out of that red rectangle. So I might rewrite 2 times 3 as 6x e to the x. And now, what's the GCF in that red rectangle? I think both those terms have a 3, and both those terms have an e to the x. So I think I can take out another 3 e to the x, which leaves me with something plus something. And to the left of that blue plus sign, if I take out a 3 and an e to the x, I think all I have left is an x. And then to the right of the plus sign, if I take out a 3 to the x, and I took out everything just to plus 1. Let's finish this now. There. So I see a 6 and a 3, which is 18. x. Now, let's talk about e to the x times e to the x. I can write this a couple ways. I can write it like this. I'm writing this over here because that's not how I'm going to write it. But it certainly is e to the x times e to the x is that. But when I raise a power to a power, I can multiply the exponents, and I can multiply x and 2. That's going to be e to the 2x, which is e to the x squared. But you're going to see it's simpler to be e to the 2x. And get rid of this now. And then I have x plus 1. So again, the important thing here to recognize is that the first function is a composite function. I had to start with the chain rule, and then along the way, while using the chain rule, I had to product rule it. Okay, I've got a few more examples to do, and they all show something different. At least, let's see, I'm not going to do that one. I'm going to do, okay, so now what about this? Am I, that, okay, okay, yeah, two more to do. So first, let's talk about what if it's a composite function that has more than two functions? What about f of g of h of x? Well, let's look at the example. Cosine of 1 minus 2x squared. And I'll remind you with this whole trig notation, that does not say this, cosine 1 minus 2x. That's not what it says. That'd be a different function. I could do that one also, but we're not doing that here. Oh, I should have picked a bigger eraser. Sorry. There we go. So my inside function here is 1 minus 2x. I'm working my way outward. My next outside, my outsider function, I'm calling here my middle function, is something squared. And my outsidest function, I'm not thinking that's a word, is the cosine of something. So I need to use the chain rule. My chain has 3 links here, if I could follow this kind of silly chain metaphor. So now we have to just start from the outside. What's the derivative of my outside derivative is cosine of something. What's the derivative of the cosine of something? The derivative of cosine is negative sine. Let's not change the inside at the moment. The inside is 1 minus 2x squared. Now, times the derivative of the inside. Now, the inside is 1 minus 2x squared. It's its own little chain rule. We got to kind of keep working our way in. So now the derivative of 1 minus 2x squared, we have to start from the outside of that, which is something squared. And the derivative of something squared is 2 times that something to the first power. And then lastly, I have the derivative of its inside. The derivative of 1 minus 2x is just negative 2, I think. So I think there that is. And this cleans up, I'm happy to report this cleans up very little. I might rewrite the first time negative sine of 1 minus 2x squared. And then, now what? I've got a times 2 and a times negative. That's times negative 4. And then times 1 minus 2x. And now that looks sloppy. I might move this out with that. So negative times negative 4 is just 4. And then we've got, I might put the 1 minus 2x before the sign. I always put the trig function last, so I keep track of what I'm trig functioning. I think there it is right there. So that's just an example of a chain rule that has more than one link. Okay. And then one more, I think, easier one. But it's a little product rule, chain rule. That's a product. E to the x squared, I'm sorry, x squared times e to the negative x. It's a product. So let's product rule it. So y prime equals, let's see, product rule. The first times the derivative of the second. I've got to be careful here. The derivative of e to the something. I would argue that's a little chain rule. I know you know this, that if y equals e to the x, then its derivative is itself. We love that function. But what if y is just e to the negative x? I would argue that's a chain rule. Inside function, negative x. Outside function, e to the something. The derivative of e to the something is e to the something, unchanged. And then you have to multiply by the derivative of the inside. The inside here is the exponent. The derivative of negative x is negative 1. Negative 1, sorry. So that would just be negative e to the negative x. So I did all that up there because that's now going back to my problem. The first times the derivative of the second. The derivative of my second is, in fact, negative e to the negative x. That's the first times the derivative of the second, plus the second, which is just e to the negative x, times the derivative of the first, which is, what, 2x. Now that stuff is irrelevant. Okay, now let's talk about how I clean this up. Talk about GCFs. I think both terms have an e to the negative x, and both terms have a x. I think that's my GCF. So I can pull out the GCF of an x e to the negative x, and I'm left with something plus something. You notice I do that every time. If I'm pulling out a GCF, I got to keep track. I got to figure out something's left before and after the plus sign. So before the plus sign, if I factor out an x and an e to the negative x, I have one x remaining and I have a negative sign remaining. So that just looks like that, I guess. And then to the right of the plus sign, if I factored out an x and an e to the negative x, I think all I have left is a 2. Now you could argue that's finished, and you'd be right. But the way the AP test likes to put this, I lost the negative sign. The way the AP test likes to put this, instead of negative x plus 2, it's going to write it like that. Not better or worse, but that's how the AP test does it. Okay, so we can acknowledge that these problems take practice and take time. So the assignment I'm about to share with you right here is not short. I'm aware of that. It's Friday morning. I'll make it due Monday night, and I expect there to be issues. So I will tell you what. Here's what I'm going to do. I am going to eventually post my solutions to this. And this is one of these things, and I don't know how to say this to you all other than here in a video since I don't see you all. This is something that if you're not going to battle through these, you have no chance of that, like none. So I'm going to post the answers, and if you're going to wait for my answers and just write stuff down because I gave the answers, that's wasting everybody's time. So you do need to battle through these. And I am going to post the answers. And the next assignment is going to be the even ones related to these. I'll actually probably post that assignment today as well. Not a new video. Just the first assignment will be these odd ones. The second assignment will be the even ones associated with that. And I'll have solutions for the odd ones, which should help you with the even ones. So both those assignments will get posted today. Probably make them both due Monday night. Yeah, Friday, Saturday, Sunday, Monday. That's 4 days. This will take you a while. Get busy on them. And use the answer keys that I will post for the odd ones. I'm not going to post a video of me working them out. I'll just post a PDF of the solutions. So there you have it. Have a great Friday. Have a great weekend. And I'll go like this. I'm going to shut this down. Okay, bye.